This is Lesson 2.2, Using a Problem-Solving Strategy. Our learning objectives are to use problem-solving strategies for word problems, solve number word problems, solve percent applications, and solve simple interest applications. There will be a lot of word problems today, and that's for a reason. We're trying to develop your skills in different real-world scenarios of solving linear equations. Now, here's a how-to 7-step process how to use a problem-solving strategy for word problems. Step 1 is to read the entire problem. Make sure all the words and ideas are understood. Step 2, identify what you are looking for. Step 3, name what you are looking for and choose a variable to represent that quantity. Step 4, translate the English sentence into an algebraic equation. Step 5, solve the equation using proper algebra techniques. Step 6, check the answer in the word problem to make sure it makes sense. And step 7, answer the question with a complete sentence. We will get out a lot of word problems for you to consider, and I will talk you through them. Example 2.14 says, normal yearly snowfall at the local ski resort is 12 inches more than twice the amount it received last season. The normal yearly snowfall is 62 inches. What was the snowfall last season at the ski resort? Well, we have a comparison of last season with the normal yearly snowfall. It's 12 inches more than twice the amount it received last season. So let's write an expression. The amount it received last season is what we're looking for. We can call that the variable x. But the normal yearly snowfall was double that and 12 more, right? 12 inches more than twice the amount. Now, reading this next sentence, it says the normal yearly snowfall is 62 inches. They've told me directly what it is. So I can write 62, and I can take these two expressions I've written and set them equal to each other. Now, I've created a linear equation that I can solve. So, looking deep at this, I could subtract 12 to start to get the variable x by itself. And now I have 2x equals 50. Next, I'll divide by 2. I have now gotten the variable x all alone, and it equals 25. Well, let's go back and think about what x represented. X represented the amount of snowfall from last season at the ski resort. So I can write last season there was 25 inches of snowfall. So I've put my answer of x equals 25 into a statement to relate to this real world scenario. Great. Let's move forward. So now we're going to talk about solving number word problems. Now you'll recall really quickly that when you add two things together, their result is called the sum. When you subtract two things one from another, their result is called the difference. When you multiply two things together, their result is called the product. And when you divide one thing from another thing, that is resulting in a quotient. So sum, difference, product, and quotient are very important words as we move forward. Let's read example 2.15. The sum of 7 times a number and 8 is 36. Find the number. All right, underline key details that you read. Okay, so a sum of 7 times a number and 8. Let's go ahead and write that. So 7 times a number, let's call the variable n because it's our number. We could call it x, we could call it whatever we want to. In this case, I'll call it n. So 7 times n is summed with 8. And now I'm told that it's equal to 36. Is the same thing as equals. So I'm going to write equals 36. All right, so I have translated this whole statement into a math equation, an algebra equation. Now it's time to solve the equation I've created for the variable. First, we'll subtract 8. And we'll find that 7n is equal to 28. We'll now divide by 7. And we've found the answer for the variable n. 28 divided by 7 is 4. So the number that they're asking for is 4. The number in question is 4. Great. Let's look at example 2.16. The sum of two numbers is negative 15. One number is 9 less than the other. Find the numbers. All right, so reading this, we'll start one at a time, like first sentence. The sum of two numbers is negative 15. So those two numbers, I could call them x, and I could call the other one y, since I already used x. And I know that when I sum them together, they equal negative 15. All right, now let's look at the next statement. One number is 9 less than the other number. So if I wrote that in a statement, it would kind of be like y. Well, that number is 9 less than the other x. So y is x minus 9. Now, what I can do with this information is I could take that x minus 9, and since I know it equals y, I can replace y with it. Rewriting all of this, I would have x plus x minus 9 equals negative 15. So I've just replaced something that I know y equals with y. Now I don't have any y's, all I have is x's, and I can solve this linear equation. So I could take x plus x and make it 2x. And then this negative 9, I could add 9 to the other side. Okay, so rewriting this all, I would have 2x equals negative 15 plus 9, which gives me negative 6. I now divide by 2, and I have found out that x is equal to negative 3. All right. Now, I have found one of the two numbers. It's x equals negative 3. But how would I find the other number? I can take that answer I just got and go plug it in right here for x. So I now know that y will equal negative 3 minus 9, which equals negative 12. So y equals negative 12, and I have found both numbers. Now, oftentimes it's good to check to see if we've got the right answer, because we know that they have to add to negative 15. Does negative 3 plus negative 12 equal negative 15? Well, yes, it does. So at least I know that it's a possible solution, and it makes sense that these would be the correct answer. All right, let's move forward. We have a definition. Let's talk about consecutive integers. Consecutive means in a row. So if I pick an integer like the number 1, the next consecutive integer would be 2, and the next consecutive integer would be 3. All right, so we're just adding 1 to each number. Now, if that's a variable, then we'd start with the number n. The next consecutive integer would be n plus 1, and the next consecutive integer would be n plus 2, etc. So here's a list of consecutive integers, like maybe I start really high, 25, 26, and 27. These are 3 consecutive integers because they just increase by 1 at a time. All right? We could also encounter consecutive even or odd integers. Now, no matter what number we're dealing with, to get to the next even number, we would add 2 to that number that we have. And then we would add 4 to that original number to get the next consecutive even integer or odd integer. So let me show you that that's kind of true. So if I had 36, 38, and 40, these are 3 consecutive even integers. And to get from the original number 36 to 38, I'd have to add 2. And then I'd add 2 again to get to the next integer. Okay? So I'm just adding 2 over and over again. But if my original number, I didn't know it and I said it was in, well, I'd have to add 2 to get to the next even integer or odd integer. And to get to the next one, I'd have to take the original number and add 4, right? Because I'm adding 2 and another 2. So that's the idea. Let's go ahead and jump in and see this in action. Example 2.17 says find 3 consecutive integers whose sum is negative 54. So I can create an equation that says, well, n plus n plus 1 plus n plus 2 equals negative 54. Let's explain that again. So I don't know what the integers are, but I know the first one, I can call it n. The next consecutive integer would be that same number plus 1. And the integer after would be that original value plus 2. So n plus 1 plus n plus 2, right? I'm summing them together, all 3 of these consecutive integers, and they equal negative 54. I can now use a strategy to solve this equation. All right, so let's combine like terms. For example, n plus n plus n gives me 3n. And then this positive 1 and positive 2 gives me a plus 3. And that equals negative 54. Now, I'll subtract 3 from left to right. I'll write the resulting equation here on the left. So I get 3n equals negative 57. I'll now divide by 3, and I find out that n is equal to negative 19. Okay, so I found the first integer. Now let's remember that, hey, that's what we were trying to find. We were trying to find n. Okay, we have found it. And so the 3 consecutive integers would be negative 19, next would be negative 18, because, right, negative 19 plus 1 is negative 18. And then the next consecutive integer would be negative 17, because negative 19 plus 2, like we have here, is negative 17. All right, so these are the 3 consecutive integers that we were to find. Let's try this again. Example 2.18, find 3 consecutive even integers whose sum is 120. One of the keywords here is even. So we can create an equation where we have n plus the next consecutive even integer, n plus 2, plus the next even consecutive integer, n plus 4. Okay, so even means that we increase by 2 every time, or odd means that we increase by 2 every time. Now, this expression that I just created will have to equal 120. Their sum is 120. Now, let's go ahead and clean this up. So I know that n plus n plus n gives me 3n. And then I still have a 2 plus 4. So I'm going to add those together to make 6. So 3n plus 6 has been the cleaned up result of the expression I created, and it equals 120. Now let's subtract 6. I will write the resulting equation here on the left side for a little more space. 120 minus 6 gives me 114. And now I'll divide by 3. And 114 divided by 3 gives me 38. Okay, so I have found that n equals 38. Well, what were the 3 consecutive integers, even integers then? Yeah, if the starting point was 38. Well, I'd have 38 as the first integer, and then I add 2 to get 40, and then I add 2 more to get 42. These are the consecutive even integers in question. All right, moving forward. Example 2.19. A married couple together earns $110,000 a year. The wife earns $16,000 less than twice what her husband earns. What does the husband earn? Let's break it down sentence by sentence. That married couple has a husband and a wife. So let's use H and W as the amount that each earns respectively. So H plus W, if I add their earnings together, they make $110,000 total. That's our first equation that we have found. Let's move on to the next sentence. The wife earns $16,000 less than twice what her husband earns. Let's turn that into an equation. So we could say W equals 2 times H minus 16,000. Let's explain. So the wife makes 16,000 less than 2 times her husband. This should make sense now. Okay, now something we can do is we can take this W and replace it with 2H minus 16,000. That way we only have one variable in our equation. I'll rewrite it all. I have H plus 2H minus 16,000 equals 110,000. All right, so this stuff right here that I just put in, it's the W stuff, right? So W became 2H minus 16,000. Now we can solve this equation. So 1H plus 2H is 3H, and then we've combined those like terms. We should add the constant of 16,000 to the other side of the equation. Rewriting everything would give us, well, 3H equals 126,000. Now we need to divide by 3, and we have found what the husband makes. The husband makes $42,000 a year. Great. All right, so now that we know the husband makes $42,000 a year, we can take this information and find out how much the wife makes if we need to. But in this case, they say the question was, how much does the husband earn? We have found that, and we're done. If we want to find out how much the wife makes, we could take our answer and subtract it from 110,000. Right? 110,000 minus 42,000 will tell us how much the wife makes. Great, you've made it through some word problems now. I really think as you read and convert from sentences into math equations and start to practice solving, you're going to gain some critical skills for when you encounter real world scenarios. Let's go ahead and move on into the next section about solving percent applications. So a lot of times we're going to have uh, percentages that we have to multiply with something else to find certain values, right? So if there's a sale at the store or if things have been marked up, then we need to know how to find, sale prices and things like that. So let's just move straight into this section. Translate and solve. Part A. What number is 45% of 84? To answer this question, we could take 45% and turn it into a decimal. To turn it into a decimal, we move the decimal place 2 places to the left. So 45% becomes 0.45. Now we take that and we can multiply it by 84. And 0.45 times 84 is 37.8. This is the answer. So 45% of 84 is 37.8. Let's try another. 8.5% of what amount is $4.76? Well, to answer this question, it's a little different. I would take $4.76 and I would divide it by 0.085. I'm turning 8.5% into a decimal by moving the decimal place 2 places to the left. And remember, if there's any empty spaces, fill them with zeros. So 8.5% becomes 0.085. Now, taking 4.76 and dividing by 0.085 gives us 56. And we're talking about dollars, right? So $56. Okay. Next, 168 is what percent of 112? To answer this question, we could take 168 and divide by 112 to get the answer. When I take 168 divided by 112, I get 1.50. Now, they asked me for a percent, so I need to move the decimal 2 places to the right to turn things from a decimal into a percent. I'm going to move 2 places to the right, and I find that the result is 150%. Great, let's give these kinds of things some more real-world context. So example 2.21, the label on Audrey's yogurt said that one serving provided 12 grams of protein, which is 24% of the recommended daily amount. What is the total recommended daily amount of protein? So if you take 12 grams of protein and divide it by this percentage as a decimal, you'll get the answer. So I'm going to take 12 and divide it by 0.24. Remember, we're moving the decimal 2 places to the left to turn a percentage into the decimal. Now 12 divided by 0.24 is 50. So we've answered the question. The total recommended daily amount of protein is 50 grams. Example 2.22. Veronica is planning to make muffins from a mix. The package says each muffin will be 240 calories and 60 of those calories will be from fat. What percent of the total calories is from fat? Well, we've got 60, and that'll be the numerator of a fraction. 240 will be the denominator of that fraction. And so 60 divided by 240 is 0.25. Converting that into a percentage, because they asked for a percent, that would give me 25%. So 25% of the total calories from the muffin is from fat. Great. Here is just a two-step process for how to find percent change. Step 1 says find the amount of change. Now, the amount of change is the new amount minus the original amount. The amount of change is equal to the new amount minus the original amount. Step 2, find what percent of the amount change is of the original amount. Let's try a couple of these problems. So example 2.23 says, recently the California governor proposed raising community college fees from $36 a unit to $46 a unit. Find the percent change and round to the nearest tenth of a percent in your answer. So step 1 is to find the amount of change. Okay, so let's say change equals the new amount. Well, they want to increase it to $46. That's the new amount. Minus the original amount. That was $36. Okay, so remember, change is the new amount minus the original amount. And 46 minus 36 is 10. So we see that there was a $10 increase. Now let's go ahead and find what percent the amount of change is of the original amount. So we're going to take the change that we just found and divide by the original amount. Okay, that's what we're doing. So the change we found was 10, right? We found 10 as our amount of change. And then the original amount that we had was $36. Okay, that was our original amount, 36. And 10 divided by 36 is 0.27. And that 7 goes on forever. Well, we've got to turn this into a decimal. I'll take the sevens a little further, just for fun. And sorry, we've got to change this from a decimal to a percent, so we're going to move the decimal place to the right 2 places. And our answer is 27.7%. Great. Moving forward. And let's talk about discounts and markups. So a discount is when you have a reduction in cost of an item, right? So we're talking about sales. And so one important thing to consider is that the sale price should always be less than the original price, right? If you're at the store and you're buying something on sale, well, you just assume that that means that it will be less than the original price. A couple important equations are that the amount of discount is equal to the discount rate times the original price. The sale price is equal to the original amount minus the discount price. Now, a markup is the opposite of a discount. A markup is when you increase the price from a certain level. So in this case, we call it the list price, and it should always be more than the original price. Now, the amount of markup is equal to the markup rate times the original price, and the list price is equal to the original amount plus the markup. These could be useful as we move forward in examples. Example 2.24 says, Liam's art gallery bought a painting at an original cost of $750. Liam marked the price up 40%. Find A, the amount of markup, and B, the list price of the painting. All right, So for part A, let's find the amount of markup. We're going to take $750, the original cost of the painting, and multiply it by 40% as a decimal. We'll write it as 0.40. Multiplying these together gives me $300. So that's how much they increased the price of this painting. So Liam increased it by $300. So the question comes up, now what's the new list price of the painting? Well, that would be the original amount plus the markup amount that we just found. All right, so we're just going to take the original price plus the markup price. Well, that's equal to 750 plus the markup I found of 300, which gives $1,050. All right, we have found the price after the markup now. Okay, that's now the list price of the painting. Let's move forward. Our last objective today is to learn to solve simple interest applications. Now, simple interest has to do with banking scenarios and how much money you earn when you put things in a savings account or other things like that. And this is the simplest form of interest. So let's define it. Simple interest. If an amount of money, P, which is called the principal, is invested or borrowed for a period of T years at an annual interest rate R, the amount of interest I earned or paid is I equals P times R times T. All right, so this formula has four variables. I is the interest. That's the amount of money after a certain amount of time that you make. P is the principal. That's the original amount of money that you put into savings, things like that. R is the interest rate. Okay, we always turn, if the interest rate is in a percent, we always turn the interest rate into a decimal by moving the decimal place 2 places to the left. And T is time. And time is measured in years. Okay, so we always have to measure time in years. And we can use this formula to compute some simple interest. So example 2.25 says, Aurelie invested a principal of $950 in her bank account that earns simple interest at an interest rate of 3%. How much interest did she earn in 5 years? Great. So they just gave me the principal, $950, right? We can write a P next to it. And they gave me an interest rate, that's R, and they gave me amount of time, that's T. They gave me P and R and T, and if I multiply them all together, that gives me the interest I. Let's find it. So I will equal 950, that's my P, times R, the interest rate. Careful, turn it into a decimal. 3% is 0.03. And then multiply that by T, in this case, 5. Make sure T is in years. And when I multiply 950 times 0.03 times 5, that gives me $142.50. This is the interest earned. This is like just, letting your money sit idle in a bank account that has an interest rate. And using simple interest, you would make $142.50 in those 5 years, doing nothing with that $950. Moving forward, example 2.26. Hang borrowed $7,500 from her parents to pay her tuition. In 5 years, she paid them $1,500 in interest in addition to the $7,500 she borrowed. What was the rate of the simple interest? Well, in this problem, they have given me the interest, but they didn't give me the rate. So my goal is to find the rate, R. Let's input everything into the equation that we can. Okay, so I, the interest, well, that was $1,500. And that interest is equal to the principal, 7,500, times the interest rate, R, times the time, which was 5 years. All right, so there we go. 1,500 equals 7,500 times R times 5. That is I equals P times R times T, where I've input all the things that I know. Now I need to solve for R. To solve for R, we could divide the values of 7,500 and 5 multiplied together to the other side of the equation. All right, so R, the interest rate, will equal 1,500 divided by 7,500 times 5. And computing that gives me 0.04. Okay, now maybe we turn that into a percentage. So the interest rate that we have just found is a 4% interest rate, right? 0.04, when I turn it into a percentage, is 4%. That's a pretty fair interest rate that Hang's parents are offering her. It's equivalent to many of the rates for student loans these days. Example 2.27, Sean's new car loan statement said he would pay $4,866.25 in interest from a simple interest rate of 8.5% over 5 years. How much did he borrow to buy his new car? The amount that he borrowed is the principal. That's what they're asking us. They're asking us, what is the principal? So let's take our interest formula, I equals P times R times T, and we're going to fill in everything we know. The thing we don't know is the principal P. All right, so this is the interest, $4,866.25. So let's replace I with that. And it's going to equal P times the interest rate of 8.5%, which we need to convert to a decimal. Moving the decimal place 2 places to the left gives me 0.085. And it's a loan for 5 years. So I then multiply it by 5. That replaced T. Now, to solve this equation for P, I need to get P alone. So I'm going to divide 0.085 times 5. You know, this stuff, it's all being multiplied. So inverse of multiplication is division. I'm going to just divide it over here. And so now I can find what P is. The principal is $4,866.25 divided by 0.085 times 5, which gives me $11,450. This is the amount that Sean borrowed so that he could purchase his car. All right, that was the principal. Great. Well, we have completed lesson 2.2. We saw a lot of word problems and a lot of different scenarios. Best wishes as you work on your homework, and I hope you have a great day. Thank you.